Hi guys, greetings. Here we are to learn about the two major things which are booming in the market currently. Number one, IoT. Number two, Python for IoT. Of course, both of them are going on parallelly in this current market scenario where both of them are a current fad for both both software as well as hardware engineers. But this is not a passing away fad. This is going to be there for a long time for sure because this covers almost all aspects of programming as you can see as we proceed with the course. Okay, so why Python is so predominant? You can have a look here. In 2015, Python formed 31.2% of the chunk where where it's the most popular coding language in 2015. Then came Java, then came C++, C Sharp, C, and so on. Okay, so you can have a look at how the popularity of Python in the recent years has grown. Why so? Why is it so popular? Here comes a question. Here are three simple solutions or notable advantages of Python, but it's not the only advantages. This is just something which you can say which is the most essential or the notable advantage of Python. Here we are. The first one is it's a very simple language to learn and easy to implement and deploy. Why so? Because any person, whether even if he wouldn't have a programming background, could learn this particular language. It is very simple to learn, as we can see in the upcoming modules. Okay, so it is it is not that tough even for an electronics or a hardware engineer or even a 12th standard or a 10th standard student to learn. It is growing in the market, not only in the Indian market but also abroad. All right, so this is very simple language to learn and it is very easy to implement and even deploy. Okay, second point, it is portable, it is expandable, and it is embeddable. Portable, it can be ported from one system to another system. It can be expanded from one program to another program. It can be embedded in systems. Say for example, in different microcontrollers. Say in IoT, say if you use Raspberry Pi or if you use Intel microcontroller, both of them, if you use Python, you can use the same script for both of them almost. So it is embeddable in most of these particular microcontrollers. The third and the most important thing, it has a huge community which provides a lot of support and libraries for the language. This is one of the main advantages of Python, where a lot of libraries have been evolved for implementing different solutions. Python has a key line which I want you to remember as we proceed. A key line: don't focus on the syntax, but focus on the problem. Don't focus on the syntax, but focus on the problem. It says you try to solve your problem, but don't leave the syntax to us. Let's take care of the other unnecessary matters, or maybe necessary, essential, but not essential for a hardware programmer, electronics programmer, or some sort of engineer who would not need to know the low level constructs of the language, but he needs to do a particular task. He needs to say, he needs to take a particular, he wants to take a photo or using his microcontroller and transmit it over the internet. He doesn't need to know the inner constructs of the program, yes, but he needs to know how to do the task. Hence Python goes with this particular comment which says don't focus on the syntax, but focus on the problem. Okay, what are the use cases in the Internet of Things? What is the Internet of Things, by the way? The Internet of Things, in layman terms or in very simple terminology, is nothing but a thing given some sort of intelligence and then connected to the internet. So if I say a thing, can I think of a washing machine, or I can think of a microwave oven, or I can think of a refrigerator, or I can think of anything. Say for example, from your bed to your fan, anything that you can think of. If you give it some sort of intelligence to think, okay, that intelligence can be given by a controller. It can, say for example, in a refrigerator, the refrigerator can be made to think whether it has a particular ingredient, or it already has a particular component, or it doesn't have. Say for example, whether it has butter, or whether it has milk, or whether it has or does not have. And if it doesn't have, that particular thing, then it can sound an alarm to the surrounding world saying, okay, I don't have this particular thing, I don't have this particular milk, or I don't have this particular butter in me. So you're giving it some sort of ability to think, but still it is not networked to the internet. When we network it or connect it to the internet, we get something called as the Internet of Things. Okay, so now when something goes low in the refrigerator, then, or say for example in the washing machine, if if the soap goes low, if soap is not available, then say for example the washing machine can pre-order your soap for you from the market. Okay, it can just look up online and just order it for you before you could think about it. That's Internet of Things. So a thing given some sort of intelligence and internet connectivity is the Internet of Things. Okay, it's gonna be a big network world by 2020. Yes. So there are a lot of applications and use cases in the Internet of Things. A few of them which are shown on the screen as of now. Okay, number one, as you can see, is a wireless sensor networks. Okay, so you have a lot of sensor networks which need to be networked together, and there you have one of the use cases of the Internet of Things. Then you have data analytics. A lot of data which is there available needs to be analyzed. Cyber physical systems, big data, machine learning, real-time analytics and processes, where you need to make you have a lot of real-time analysis, a lot of learning, making the machine learn how to think, how to program and stuff like that. So for all these particular tasks, can I say I need one programming language which spans all these diverse fields? There are a lot of diverse fields out. If I could get one programming language which we could just use for all these fields, is it possible? Yes, here comes Python. Okay, Python has a vast library support which can help you or aid you in all these particular tasks. Okay, so you have the first of all, you have the GPIO library, as you can see, or the GPIO 0 or the MRAA library. What does this do? It is a skeleton GPIO library for most of the controllers which support Python. Okay, so for example, the good thing about it is there is just one library for all devices, so I don't have to use different ones for Edison or for a Pi. That is Intel Edison or a Raspberry Pi. Okay, so it is a high level library. You can read and write to pins in one lines. You can use protocols such as I2C, UART and SPI. Maybe it may seem Greek and Latin to you for now, all right, but we are going to learn in the course how to use the GPIO pins, or how to talk to the external world by sensing some external phenomenon, or making some actions to happen using actuators. So you have sensors and actuators which are going to be connected, and you are going to use the GPIO or the GPIO 0 or the MRAA libraries to talk to the external world. Your microcontroller could talk to the external world. What about sockets? Okay, sockets are nothing but which socket is a package which helps you to actually talk or facilitates networking over TCP/IP and UDP over Python. So basically, you can use sockets for communication two between two controllers, between a controller and a processor, between client and servers, um, using using a particular using that particular library. You can go for the protocols like TCP/IP, and you can create socket level programming. So you can use sockets library for using that. Okay, so you can even build your own communication protocol using this package as the base. So the next one that you have is MySQLDB. So a database is, as you know, it's not uncommon when it comes to most IoT applications. Okay, so you have you say for example, you have if for IoT the entire sole purpose is to send data to the internet. So that means there must be a database. So there must be at least a remote database which stores all this generated tasks. So MySQL is the go-to relational database for most developers. So in this case, we can say MySQLDB is the library which is going to help you to talk and to fetch data or to give data to an SQL. So we are going to see how to use that. Okay, then you have something called as the NumPy library. Okay, so we might have used as a electronics engineer, we might have used MATLAB a lot of times, but you might you don't know how to deal with, you might have dealt over there with using something where you have something like matrices and stuff like that. So you might have a lot of data which, sensor data in bulk from databases, and you want to work on them using inbuilt functions. How can I do that? Python provides it with a library called as numpy. Okay,